Hello everybody, my name is Gordon Harding and thank you for listening to my presentation. Today I'll be talking about the research project I did for Holland College, in which I found Endobacteria may increase glucosinolate production in broccoli sprouts. Now let me start by first introducing some of the key characters at play here. In nature, most plants will form a symbiotic relationship with a fungus called mycorrhizal fungi. Now there are two main types of mycorrhizal fungi, of which arbuscular mycorrhizal fungi act as host to Endobacteria, both of which give the host plant access to a slew of advantages, such as increased nutrient uptake and increased stress tolerance, both of which also outcompete possible pathogens and establish a successful microbiota within the host plant's root system. Endobacteria in specific have been investigated lately for their potential use in sustainable agriculture products, specifically for their incredible ability to cycle nutrients and to produce oxidants and other useful compounds, including indole-3 acetic acid. Interestingly, broccoli sprouts are one of the few plants that cannot support mycorrhiza and therefore are considered to not support endobacteria. This means that they miss out on all of the advantages provided by the microbiota. And because of this, much research has gone into how to introduce this microbiota or other microbiota to broccoli sprouts and further increase their production capability. Furthermore, broccoli sprouts have been shown to produce large amounts of glucosinolates, such as glucoraphanin, which are considered to be health-promoting compounds. Although research into this is still ongoing, it is promising. Much research has gone into how to increase the glucosinolate concentration within broccoli sprouts, and this has been promising, showing that treatments like UV light, difference in water schedules, light schedules, and harvesting times can all influence the glucosinolate production. It's also been shown that treatment with indole acetic acid can increase the glucosinolate production in broccoli sprouts in hairy root cultures. Considering this, we hypothesized that if an endobacteria were able to exist within the soil and produce enough indole acetic acid to increase the soil's concentration of the compound, then it would be able to influence the broccoli sprout growth and the glucosinolate concentration of the plant. Now, in our growth trial of broccoli sprouts, in which we treated broccoli sprouts with several different unidentified endobacteria and a known endobacteria culture, P. polymyxa, we found that the known culture was able to actually stunt the plant growth close to that of an indole acetic acid standard that we also treated sprouts with. Interestingly, another unidentified endobacteria culture, UEB4, was able to stunt the growth of the broccoli sprouts almost as much as this culture. Furthermore, this one culture, UEB4, produced around 0.8 milligrams per mil of indole acetic acid in the Sulkowski's assay, and this was around 4 times as much compared to all other UEB cultures, which would likely explain the stunted plant growth. The standard P. polymyxa culture, or PP, produced around as much indole acetic acid as the other UEB cultures, shown in C, although it was able to still significantly reduce the plant height, shown here. This shows that PP probably has another method of reducing the plant growth. Now, if we look at the UPLC analysis of our glucosinolate production in the broccoli sprouts, we see that our untreated control, B, produced around 2.7 micrograms per gram of desulfoglucoraphanin per gram of broccoli sprout. Most of our UEB cultures, 1 through 15, were able to increase the desulfoglucoraphanin concentration to around 30 micrograms per gram, and UEB4 increased it to around 86.2 micrograms per gram. It is likely that UEB4 was able to increase the DSGR concentration so much more so due to the increased amount of indole acetic acid that the culture produces. Furthermore, the indole acetic acid standard and the P. polymyxa culture were able to increase the DSGR concentration to around 130 micrograms per gram, which is incredibly more than the UEB cultures. This is likely because the indole acetic acid used was actually within the inhibitory range, which would stress the plant, causing it to produce more glucosinolates. And the same can be said about the P. polymyxa culture. Our study shows that Endobacteria is able to influence broccoli sprout growth through production of compounds. Furthermore, Endobacteria are also able to increase the glucosinolate production within broccoli sprouts, and some of them are able to do so without reducing the plant growth. This shows that some of the endobacteria in our study may warrant further investigation into use in sustainable agricultural products geared towards producing a healthy organic broccoli sprout product. Thank you very much for listening to my presentation. I would like to thank all of the wonderful staff and students at Holland College for their help along the way, as well as phytocultures for their significant contributions to the study.